Knowing about the limit laws gives us a shortcut for calculating a lot of limits, but it turns out that most of the interesting limits that we need to calculate will fall into one of the gaps of the limit laws. Remember, the quotient rule for limits says that the limit of a quotient is the quotient of the limits if the denominator isn't 0. And it turns out that for all of the interesting limits, the denominator is always 0, of course. For example, on this one, the limit as x goes to 4 of x squared minus 6x plus 8 over x squared plus 3x minus 28. If you try to use all the limit laws to calculate what this limit is, you get, in the numerator you get 0, and in the denominator you get, well, 0. So you get 0 over 0. It's tempting to say that 0 over 0 should be, well, maybe it's 0, or since you're dividing by 0, maybe it's not defined. It's hard to say, but the problem with 0 over 0 is that it actually might be 0, or it might not be defined, or maybe the limit is 1, or maybe it's minus 3. It really depends on how you end up with 0 over 0. So getting 0 over 0 for a limit just means that we need to try harder. If you ever get 0 over 0, try harder. So let's see what else we can do. Well, for this limit, the numerator and denominator are polynomials, so we could just factor both of them. And we get the limit as x goes to 4. Let's see, in the numerator, this factors as x minus 4. And in the x minus 4 times x minus 2. Just to check, you can multiply this all out. You get x squared minus 6x plus 8. And in the denominator, this also factors. This is x minus 4 times x plus 7. You see that with this x minus 4 in the numerator and denominator, we can cancel those. And now if you use the limit laws to calculate this limit, you don't get 0 over 0. If you plug in 4, you get 2 over 13. So this limit is 2 over 13. The key point that happened right here is this cancellation. This cancellation really only happens when x isn't 4. But remember, the limit doesn't care what happens at 4. It only cares what happens near 4. And so it's okay to cancel these factors of x minus 4. All right, so that's one good trick for calculating a limit. If your numerator and denominator factor, you might need to factor them. Let's look at another example. All right, so let's find the limit as x goes to 4 of 1 over x minus 1 over 4 all over x minus 4. Now again, if you just try to use the limit laws to calculate this limit, in the numerator you get 0, and in the denominator you get 0. And 0 over 0 means try harder. Let's see, what try harder means exactly kind of depends on the limit that you're working with. For this limit, since the numerator is a difference of fractions, it seems like maybe we could just put them over a common denominator. That's one thing you can do with fractions. So to put these over a common denominator, on this 1 over x part, we'll have to multiply by 4 in the numerator and denominator. And in the 1 over 4 part, we'll have to multiply the numerator and denominator by x. That will give us the limit as x goes to 4 of 4 over 4x minus x over 4x all over x minus 4. And let's see, we can simplify this more. The numerator, since we arranged for a common denominator, we can combine these numerators. So this is the limit as x goes to 4 of 4 minus x over 4x all over x minus 4. This fraction is a bit of a mess, so let's try to simplify it a little bit. Limit as x goes to 4. This is the numerator 4 minus x over 4x times the reciprocal of the denominator, so 1 over x minus 4. If you look at these two factors, 4 minus x and x minus 4, they're almost the same, so maybe we can cancel them. If you mess around with it a little bit, they will cancel. So let's look at this. Limit as x goes to 4. Now 4 minus x is the negative of x minus 4. We can factor out a minus sign there, over 4x times 1 over x minus 4. And now these x minus 4's cancel. And we get the limit as x goes to 4 of minus 1 over 4x. And then we can just use the limit laws to calculate this limit. And we'll get minus 1 over 4 times 4, that's 16. So the result of that entire limit is minus 1 over 16. And we did that just using limit laws and doing some algebra. The algebra in this case was subtracting fractions by getting a common denominator. Okay, these algebra tricks for calculating limits turn out to be pretty good. Let's look at another example. Let's find the limit as x goes to 2 of x minus 2 over the square root of x plus 2 minus 2. You will probably guess that we get 0 over 0 again if you just try to use the limit laws directly. And that's true. You do end up with 0 over 0. So we need to try harder. Exactly what try harder means depends on what your limit looks like. And for this one, the only thing that really pops out at me is the square root in the denominator. One algebraic trick that you can do when you have a square root in the denominator is to multiply the numerator and denominator by the conjugate of the denominator. And that means multiply the numerator and denominator by the same square root stuff in the denominator, so x plus 2 and 2. But instead of a minus in the middle, we'll put a plus. And then we have to do that in the numerator as well. X plus square root of x plus 2 plus 2. If you haven't seen this trick before, it seems sort of weird to put a plus here, but you'll see in a second why that works. Okay, let's multiply everything out. We get the limit as x goes to 2 of, in the numerator, x minus 2 times the square root of x plus 2 plus 2. So the numerator looks pretty bad, but in the denominator, let's distribute everything. We get square root of x minus 2 times square root of x, square root of x plus 2 times square root of x plus 2. That's x plus 2. And then we get square root of x plus 2 times 2. That's plus 2 square root x plus 2. All right, now we get these two products. That's minus 2 square root x plus 2. And then finally, minus 2 times plus 2, so that's minus 4. And if you look carefully, we get some nice canceling that happens. This 2 square root x plus 2 cancels with minus 2 square root x plus 2. All right, so let's write down what we get after we do that simplifying. The limit as x goes to 2 of x minus 2 times the square root of x plus 2 over, in the denominator, we have x plus 2 minus 4. That's x minus 2. And would you look at that? We get more cancellation that happens. We can cancel a factor of x minus 2. That leaves us with the limit as x goes to 2 of the square root of x plus 2 plus 2. And this limit we can calculate using the limit laws. Plug in at 2, and you're going to get the square root of 4 plus 2, and that whole thing is just 4. So that entire limit is just 4. As you can see, lots of limits get you 0 over 0, so when you see 0 over 0, don't jump to conclusions. 0 over 0 means try harder. And much of the time, trying harder will mean doing some algebraic trick and then simplifying the results so that you can use the limit laws to calculate your limit.